Okay. Oh, I should turn on this and then I'll be good to go, right? Hello, hello. Okay. Sorry about that. Ready. So this is talk on the recommendation engine. I know the title sounds boring, but I'll assure you that this isn't the most terrible talk in the world. It's been 5 years since I've even given a talk at a PHP conference. And the last time I gave a talk at Confoo was the inaugural one, which I believe was like 9 years ago in 2010. So a lot of you don't even know who I am. So I should bring some of you up to speed about who I am. I've been a PHP developer since 2000, which is longer than most, but I hopefully not all of you in the room. My first commercial PHP website was the first internet travel search engine. Think more like Kayak rather than Travelocity. We kind of scraped things like Travelocity. Then I worked on the Home Attendant, which is like known as this. Nowadays they call it Internet of Things, but cameras didn't have IP addresses back then, so it's more direct video cables and RF signals and power line protocol called X10, where you literally sent stuff over the power line. And then I worked at Plaxo, which was a content management site. If you used YouTube in 2006, their address book importer was our product. Was actually a widget that I worked on. I also did remote scripting, which is now known as Ajax there. 2 chat systems that adopted Ajax were worked on there, Meebo and HipChat. After that, I worked at Tagged, which was a social network. It was the 3rd largest social network by the time I left. And then I decided I had enough of evil. I might give good a shot working for all those evil companies. So I joined 2 large open source PHP projects you might have heard of. One is known as WordPress and the other is Wikipedia. So yes, I was a PHP programmer. That's like the past life sort of thing. And what I became known for is something that this happened one day at OSCON. Cal Evans just started working at Zend, and he came up to me to schedule a podcast interview because he just started working. And I was realizing I was sitting next to Andrei Zemesky on one end, who was the lead developer of something called PHP 6. So if you ever wonder why there's no PHP 6, now you know. And Wes Furlong, who was known as the king of Pickle. And I was like, why are you coming up to me? Like, these are real developers. And Cal just started to pull out this deck of baseball cards, and he was flipping through it, like trying to figure out who the 2 people next to me were. And I'm like, whoa, wait a minute. What are those cards? And they're of us. And I made him cough up the cards, and I took a photo of it, and I tweeted it. It became a meme. This is my card. You can see me. There's Andre and Wes. And you might not know this, but this was a pretty intense game of Magic that was actually going on. This is a very rare, powerful card because you can see George Schlossnagle is actually a picture of Zach Grant. And if you tap my card, the audience is frozen for 1 turn due to all my cussing. Cal got his revenge on me in 2006. He actually got Zen to make a deck of cards of all the developers, and they put us on a promotional deck of cards. That's my card there. And I found, that I was thinking at the time, well, the Iraq War had just gone on, and the U.S. military was publishing this deck of most wanted cards. There's Saddam Hussein, that they were hunting down these terrorists. And that's how I became the PHP terrorist. And that's me as Che Guevara. The next year, in 2007, Zen continued the trend. They made PHP developer trading card set, which they literally called me a PHP terrorist. There it is. And apparently I was powered by the blood of young Ruby developers. Why? Well, a little bit about Ruby on Rails before I get back to the topic. Why is it the blood of Ruby developers? Well, it's because I wrote this article. See, that year, the year before was 2006. It was the year of the dog. And there are a ton of articles with the title, Is Like PHP Doomed? or other variations of that. And in fact, at OzCon, Danny O'Brien gave it a keynote speech where he was talking about, he just mentioned this at OzCon, that Gandhi is famous saying, first they ignore you, then they laugh at you, and then they fight you, and then you win. And he made the Gandhi state diagram: ignore, laugh, fight, you win. And then he noticed that Ruby didn't follow this. They optimized the procedure. It's just simply they ignore you, and then Ruby wins. And that's some serious performance optimization. They must have had a killer version of XDebug going on. And I was just, reading that year. And the next year, 2007, happens to be, well, let me explain why it was a big deal. Because, Ruby became TOB's language of the year. It was basically had one of the largest growths in that year. And the next year was the year I'm born, the year of the pig. It's my birth year. It's also the year I wrote this article. Is Ruby the dog and PHP the dog food? No, because it's the year of the pig, so I get to be a pig. And I pointed out that instead of that Ruby wins, and then I get to laugh at the whole thing. Now, I deleted all my slides about why that was the case, because we're more than just a PHP conference. Back when I first came here, it was PHP Quebec, but now it's Confoo. So I'll just say it's not about Ruby, it's not about PHP, it's really about frameworks. And so what I was trying to explain to people is I don't have a beef with Ruby. Why would I? I use Ruby all the time. I just have a beef with frameworks in general, and when we say Ruby, we really mean Ruby on Rails on the web. And I just said something like this, where Rails is like a rounded rectangle and PHP is like a ball of nails. And that's because if you throw it at stuff, it sticks to shit. And my point is that Rails may be beautiful, or any framework you should say may be beautiful, but it kind of puts you in this prefab house. And that was basically my problem in this, PHP is a ball of nails. They actually made conference t-shirts with all this. But it was just my point of the language. I have this friend, his name is Cal Henderson, and at the time he was this guy who wrote Flickr on his laptop, but now most of you guys know him as the CTO of Slack. And he was fond of saying all languages scale, not all architectures do. And Rails, or any of these things, preset the architecture, which doesn't mean that they can't scale. It just means sometimes you have to undo some of the things that attracted you to it to make it scale. You have to undo a lot of the framework to rebuild on top of that. And so all of these things could be applied to frameworks in general. They're not restricted to just Ruby on Rails. So like I said, when I say PHP is a ball and nails, PHP is just this piece of shit you just put all the parts together, and you throw it against the wall and it fucking sticks. That was my explanation 12 years ago, but it just is in general. So what I mean by this, it's the year of the dog now, by the way. I mean the year of the pig now, right now. That should say year of the pig. Is that I'm saying something, I might be ripping on Ruby or whatever. It applies to every web language. I might as well be ripping on PHP. Or if I'm talking about Ruby on Rails or Django, or when I do talk about those two things, they apply to any framework. It could be Laravel, it could be, I don't know what the framework du jour. PHP really just doesn't seem to manage to keep one for very long. And also, because this is a data talk, I'll be mentioning things like NumPy or Pandas or some other computationally intense shit. You can just replace it by R, MATLAB, or some matrix library that you can find. Good luck finding one in PHP. But heck, you never know. I mean, I never thought they would ever make hip hop, and they did. So that was an argument I had with Haiping back when he's like, Terry, you're a PHP developer. PHP developers are losers. And I'm like, you're a C++ person. You're amazing. But there's a zillion of me, and there's only one of you. And then he wrote hip hop to show that it didn't matter. He'll just write it so that losers like me can write really fast code. Well, that's the past. Let's fast forward to today. Currently, I run engineering at Clara Health. They're a small company who tries to make a patient-centric approach to connecting people to clinical trials. They're on Python and Django. which is somewhat terrible for me, but could be a lot worse. But this talk is actually about, to go back in time, my last company, where I was a principal engineer at Raise Me. What Raise Me does is they help students earn money for college in the form of micro scholarships. By moving the financial aid process to before the high school student even applies to college, the college incentivizes them to become the sort of student that the college is actually looking for. So you might make a micro scholarship for like an engineer, a math class, because you want more STEM people. Then that by the time that person applies, they will actually have taken like AP Bio or calculus, and that's basically the kind of synergy that they're looking for. But their main web stack for the purposes of this talk is it's engineering is Ruby on Rails, so that's a little bit of torture. But it was the year of the dog last time I was there, and it's just struck again. And I really wanted to start developing again, like being this director of engineering at Wikipedia was like fun, but I want to code. So the person who hired me and a major character in this story is Dave. He's the CTO and co-founder at Raise Me. He actually became that by answering an ad on Craigslist that his wife found. So FYI, if you ever want to start a company, look on Craigslist apparently. He's been a consultant since the late 1990s, so he was actually doing it longer than me. And before that, he was in a rock band. These things are actually important. You can still download his music on Spotify. And he quit smoking to take up, he stopped smoking through the magic of CrossFit. And the only thing he loves to talk more about than CrossFit is Buffy the Vampire Slayer. He named his dog Buffy. And so the 3 points in this talk are the 3 aspects of this talk. The first one is basically going to be about Clarke's 3 laws. So I'm going to just give you this discussion from the perspective of Clarke's 3 laws, which, believe it or not, you might have heard of them. I've definitely heard of one. The first law, I'm just not going to do it in order, but the first one will be the first law, and that is Clarke's first law, which says when a distinguished but elderly scientist states that something is possible, he's almost certainly right. When he states that something is impossible, he's very probably wrong. Well, we don't have a distinguished but elderly scientist, but I do have a distinguished but elderly CTO. And what happened one day when I first got hired is he said, Terry, I think it should be possible to recommend colleges to students in a manner like college search, but without any input from the user. So do recommendations, but the user doesn't have to like tell you what their preferences are. And if he were here today, he'd be saying, I have an exception to that. I'm not so elderly. In fact, I'm actually younger than you. And I do CrossFit. So that makes me quite spry. He said that in a number of one-on-ones. He said, you should do CrossFit also, Terry. It'd be impossible for you not to like it. Luckily, according to Clarke's first law, he's very probably wrong about my enjoyment of CrossFit. But what about the recommendation engine? How would we recommend it? And the answer is a recommendation engine. So what is this recommendation engine by which the topic of this talk is? Wikipedia's definition of recommendation systems here is, quote, a subclass of information filtering systems that seek to predict the rating or preference a user would give to an item. That just doesn't help much to me. Like, these kind of definitions aren't in English. So I'll tell you my version of it as an engineer. It's to use analytical data as opposed to transactional data for a user-centric purpose as opposed to a business-centric one. So I'll explain these terms, but just know that this is kind of a better definition of what a recommender system or recommendation engine is. So let's explain these terms. So the stuff on the left, even if you don't know the terms on. The stuff at the right, you don't know, but I'm going to give you the context to understand those terms. So when a user-centric thing, we might want to ask is the user wants to log into the site. The business-centric version of that is how many users have logged in the last month or have used the site in the last month? That's a typical business question. So the way we answer the user wants to log in, we select password, user ID from users where email is whatever your email address is, right? Assuming that that's the user part of the login, right? It's a very easy thing to do. We're very familiar with it. To answer the analytical question, how many users have logged in? Oh, we do that in a typical database called MySQL or Postgres or whatever. Typically, we could do it in NoSQL. And we're used to these things being relational databases. In this terminology, we call them online transactional processors because they're dealing with transactions. Okay, and I'm representing that by this like kind of database thing. In the analytical thing, we would, if we were to do it on our database, we would select count star from users where we do some join on some activity table, and we select by date. Okay. The thing to note is there's a count star in there, and there's a where on something we probably would never index, like a timestamp. So these queries are really, really expensive if we were to do them on this thing, which in this terminology is online transactional database processor, which we would call a database, right? If we did it on a standard database, we know this would take a long time to run because we're not indexing this thing and we're not doing this like table scan where there's a count star. Okay, so we need something that's specialized for that. That's called an online analytical processor. Another term for that is a data warehouse. And I'll just represent it by this kind of like warehouse thing. An example of that, as opposed to MySQL, is Paracel, which is what I used at Tagged like 12 years ago. That's also known today as Redshift, Amazon Redshift. So a regular database uses a row-based relational storage system. We're familiar with that. Well, what Paracel does, or any of these kind of data warehouses, this Paracel as an example, is they store the columns instead of storing the rows. So they store it by columns. So therefore, you don't have to index anything because it's already indexed, kind of, right? And then when we need to scale a regular database for these large sites, we typically partition the database. But in this world, we use a massively parallel processing. It's built into the product instead of us having to like partition or write something in the app layer to handle the scaling. It's handled right into the product itself. They're almost always massively parallel. And examples on AWS are RDS, and Paracel is also known as Redshift. It's the same product, it's just they're wrapping on it because they own Paracel now. So I've answered all of that, I hope, in terms of like what user-centric and transactional data is versus business-centric analytical data stores are. But how do you get the data from your users using the site, i.e. your relational database, onto this data warehouse? Well, that's another sort of concept, and you may also be bringing it from other sources like your weblog files. That's known as ETL. So when I use the term ETL, it stands for extract, transform, and load, and it's just this thing you can just look up. Like, let's say you choose Redshift as your data warehouse. You just look up ETL, Redshift, and then find a product or a piece of software that does it, or roll your own to do this. But when you need to load the data, because you're working with the data on your user transactions, but you need to load it on the data warehouse for this form of analytics, find an ETL that does it. I'm not going to go over how to do this. This is supposed to be a beginner talk. And now to understand this, a recommendation engine, to emphasize it again, is using an analytical data store like a data warehouse, but any sort of analytical data store. You could even store it on a relational database if you must. For instead of answering business questions, to help the user. That's really what a recommender system is. Okay. So I was assigned to this group called the Awesome College Discovery Crew, like AC/DC. So I can imagine Dave just saying like, "Yeah, rock on." It's like he's into rock music, so he must have liked the title of the group. And their job was to improve student college matching through connecting the students that are fit to the business metrics. Because remember, we only make money when when the user goes to a college that the user's already followed before they do it, because the colleges are really just taking their financial aid package and moving it up front. So only to the extent that it recruits that person, i.e. that student, to the university, that's when we get paid, right? But we also want to make the product more intuitive, because if we use our data wisely, then we're going to improve that matching. And if we do it right, then the student just does it seamlessly instead of having to typically do a college search. I don't know if any of you searched for college in the United States, but it's this wall. There's like 4,000 plus of them. And you just start looking and saying, well, maybe I want to have one near where I live, or some arbitrary criteria that you don't even know what you care about. Like maybe you want to just be really far away from where you live. You just want to be far from your parents. You just never know. And students really don't know how to hit this wall of search, like where like everything's available, and then filter on. Do I really want to go to a school that robotics is like great at that school? Like they don't know when they're in high school that they want to be a roboticist or something like that. So recall the two quotes. When a distinguished but elderly gentleman, a scientist, says that something is possible, he's almost certainly right. And my boss saying, I think it should be possible to recommend colleges to students, like college search, but without any input from the user. Is the CTO right? He's almost certainly right. Arthur C. Clarke says so, but more importantly, we can go to the early days of the internet. Since the late 1990s, Amazon introduced us to this with customers also bought, or these items are frequently bought together. Those are our recommender systems, right? So we've seen it in the early versions. A more recent and more relevant example is Netflix, which makes a good model for us because they're connecting users to movies and we're connecting students to colleges. But instead of a bucket, like because you watched X or popular on Netflix, it'd be because you followed this college, or this is popular at your high school. Those are kind of the sort of things we'd be considering. But you see them everywhere once you realize it, like on Twitter, on Spotify, on OkCupid, on dating sites. These are just some more examples of them. You can use them everywhere. Once you realize how a recommender works, you can use them everywhere. And the idea is to help your user do things, use like your business data to help your user do things without your user having to tell you what they want. They just their actions on the site kind of tell you what they want. If they're buying salt, they probably want to buy pepper in Amazon's case. So how do we translate that to actually getting it working? Well, this is how I actually got it working. The first iteration, the front-end recommendation system page loads. This is typical from an Ajax site. It requests the rec engine from a list of buckets from the API. It gets back a list of buckets. These are like, in this example, instead of movies with a strong female lead, like a la Netflix, it'll be because you lived in the West. Okay, so these are colleges that are in the West that you might be interested in. So that bucket ID would be West/West. It gives that bucket ID to the server, and the server spits back a bunch of results in the recommendation engine. You'll notice that there's this big hand-wavy state here where it actually gets the recommendation. So let's just open that up a bit. In Ruby, it calls this Ruby API for West, and then basically it looks up extra data. To get this extra data, Ruby attaches that from the West bucket to the actual query that goes onto it. It generates that query, sends it to the Go API, and it gets back. The Go API extracts a ranking system using either a collaborative filter or a popularity table. And then magic happens, and it generates this list of things. Then we filter the results on the Go server to just the results that are of colleges in the West. And then we return that to the Ruby on Rails API, which adds some syntactical sugar for rendering and then sends it to JavaScript. Pretty easy, right? And you may have noticed that 3 languages are involved: JavaScript, Golang, Ruby, and there's some Python magic I mentioned, so 4 languages. Well, the answer is because Raise uses Ruby, and we could have done the whole thing in Python. I need Python for the analytical parts. So if you use it in Ruby on Rails, I could have done it in Django, except we were using Ruby on Rails. So why didn't we use Django from the beginning? Like, why didn't Dave choose Django? I believe it's because of bad marketing. So instead of imagining let's just roll back our Git history, right? Instead of Django, imagine if it were called Python on a plane. Okay, I think Django should have been called Python on a plane. I think everyone would be using Django today if they figured that out. Just let's roll back our Git history 5 years ago in an alternate timeline, and imagine it was called Python. Then clearly Dave, who's this rock star, would be like in his only just slightly less distinguished but still spry youth. He was a literal rock star, so he would choose Python on a plane, rock on. But it's Django. It's actually named after a jazz guitarist, if you don't know, and a French jazz guitarist. And Dave was not into jazz. He's into rock and roll. And not only that, Python isn't even named after the snake Python. It's actually named after Monty Python. And Monty Python is not as cool as Buffy, at least to him. He's like, so like, and so he ends up choosing Ruby on Rails because it's way cooler than a bunch of English musicians and a French jazz musician. And that's why I had to spend 2 weeks learning Go. So let's get to this Clark's third law, the second part of my talk. And that is any sufficiently advanced technology is indistinguishable from magic, right? Because I talked about some Python magic happening. And so far, it's as if it literally is magic. I did some hand waving, and we came up this list of college recommendations. And I will tell you that, or maybe I'll just turn this quote into what we should be asking, is advanced technology sufficiently indistinguishable from magic? Specifically, is Python sufficiently indistinguishable from magic? And I will prove to you for all time that Python is indistinguishable from magic. And the way I know this is I have a friend who was not techie, and she just moved to San Francisco, and she told me this story. She overheard 2 people eating at a restaurant she was at, and they were talking next to her, and one of them said, what are you up to? And the other one said, well, I'm trying to learn Python. And she went up to them and said, excuse me, but I think it's called parsicle tongue. So there you go. She later found out Python's a language, but there you go. She had no idea that Python is not magic. So there, it is indistinguishable. But maybe you don't buy that argument, and we are engineers. So let's start to open up this magic. So there's 2 parts, remember. There's this part where I said some magic happens, and there's the part that you don't need Python to do. You could do in any language. The filtering part where we're just filtering our results by colleges in the West. And actually, this left part, this magic part, we're going to open it up, and there are actually 2 ways to build these rankings. One's called a collaborative filter, and the other's called a content-based popularity table, and I will describe both of them. So remember, there's many of these kind of buckets we could put them in, like lists, Netflix sort of lists. We could do a student ranking where we rank the college based on students similar to you. We could do a college ranking where we base colleges based on similar colleges. We could do a state college ranking where we base it on the student's home state. We could do a high school college ranking where we base it on the student's high school or the zip code by their location. Okay, there are many ways to do that, and I just say the first one, you use a collaborative filter, and for all the other ones, you'd use this content-based popularity table. To explain the first one, the collaborative filter, imagine we have this table and this table could be whatever, but in this case, we're just going to say this hypothetical table is the number of times the user viewed a college page. Okay, I could have used any other data, how many times they followed, or whatever sort of data that I have already in the system. And they're missing values. Can you see these missing values? They're right there because the user hasn't visited the page at all, or they're a new user, okay? Well, what I do is you just use a library, linear algebra library called matrix factorization library, and you can generate these missing matrix elements. You can find the two smaller matrices, the student factors and the college factor, that approximate this larger matrix with all the values filled in. And to see how that works, just as an example, in this case I use NumPy and Pandas to do that in Python, is just look at that first one I highlighted there. You can see these two users are the same, except for the missing data. So I know that one's about 2, right? And similarly for this one, that's 4, right? And if you did it, you could even do a more sparse matrix, and you get about 1 and about 2 in these two areas, okay? So to translate that, once we've generated this full matrix, we can just read off the values. So to remember, the highest value is the most visits, so therefore that would be the highest rank for the college. For student B, we recommend college Z, then Y, then X, then W, right? For student D, we recommend W, X, Y, and Z, and so forth, right? So how did we actually implement it? Well, once an hour, a Python EC2 instance goes to Redshift and uses its data to build this matrix factorization model. So it's using this analytical store to build this matrix, and then it stores it somewhere. It just freezes it in Pickle, right? And it just freezes it, it serializes it, and I'll just, so that I can access it really quickly later. Then my Go API server instantiates like Python inside of itself. It grabs the model, unrolls it, and looks up the user and returns the rankings of all the colleges for that particular user back. So that's how it does it. I probably should have done it in serverless, at least the part, Lambda, at least the part for building out the model, because that happens once an hour, and that's a perfect thing for something like Lambda. It's just that I was worried that the process runs too long. So that's why I actually started it as an EC2 instance. For content-based popularity table, it's more intuitive. It's the same sort of chart, except for I'm going to add another column, which is the state. Okay, so these are all the results. I'm going to sort by state, so they are sorted, and then I'm going to sum them up for a given state and just group them, and then read off the totals. So for California students, we recommend Y, then W, then X, and Z. It's really easy. You don't even need a big library for that, but you could use something for that. And the implementation is once a day, because these tables don't change as often because they're aggregate tables. We go to EC2, and it goes to Redshift, and then it uses xplenty, which is an ETL, to save that to RDS. And that's like one part I waved over. You don't want the actual transactions working directly against the user transactions working against your data store. They have to work on some sort of thing after that has been summarized from the data store. Because the idea of fast in analytical world is like once in under a few seconds, right? Which is way too slow for a user. So we want that sub-second time in the millisecond range. So we just cache those popularity tables in RDS, and then just query. The Go API server queries RDS and returns the result. Okay, and then it filters that through the content-based filter. Remember, once you have the list of all the rankings, you just go in and go into RDS to grab the select star. So I just give it all the college IDs and then just filter by colleges in the West, and now I have recommendations for the user based on colleges in the West. So that's just the last part. The two together, the generating of a ranking and then the filtering of the results, are how you would design this recommendation system, which is known as a hybrid recommender. We use MongoDB actually, so that we can actually do this select star. So an xplenty RTL stores that in Redshift, and we use another xplenty RTL to generate this filter table that we use in actual RDS. Okay, just FYI, it's just a hand-wavy thing that's not very important, but in case you're using a NoSQL database, and you're trying to do these filterings, you obviously want to have a separate sort of thing for that. Okay, so the last part of this talk is Clark's second law. Man, I have to go really fast. And it's the last part, luckily, and that is the only way to discover the limits of what's possible is to venture a little past them into what's impossible. Whenever I hear the word impossible, I start hearing that music, dun, 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 dun. And so that's what your mission is to do this, is to figure out how to use recommendations in your project. Just remember, it's you're building this intuitive UI, so anything that has a collaborative filter or a popularity table or content filter or a hybrid of those others is this recommender system. And even if you don't have access to a library, I mean a matrix library, you can use popularity table and a filter and just do it straight up, which I'll talk about that. So I'll give you 3 examples where I used it. The first is actually 2 examples where I used it. The first is I need to give this, because this is Mission Impossible, I need to give a post-credit scene. And then I'll discuss 2 sequels. One's autocomplete at my current company, and one is Meet Me at TAG, where I worked 11 years ago. The first is a mission debrief. I just might mention that because of things like this, we were able to close our Series B fundraising. A month later, they disavowed Dave, and then a month after that, they disavowed me. They got the money, and then they fired us. Great. It sounds terrible, but on the other hand, if you want to work at a recent company that has no senior engineering staff, I know a company that's hiring. And don't worry too much for me, because the very next month I started working at Clara Health. And as their head of engineering, it's time to make another recommender sequel, right? So I did it using autocomplete. So this makes a good example of using a recommender system without a data warehouse or a matrix and statistical library. So how does this work? Well, the issue is, the problem is, users searching on Clara Health for clinical trials are going to type in something like cancer or ALS. And we need to suggest the actual term in the med database that is responsible for something like cancer. Or maybe in the case of cancer, we want to suggest the most popular cancer like breast cancer. In the case of ALS, we have to actually turn it into some long word that I can't even pronounce. That is what Lou Gehrig's disease actually is. And we should do that immediately. Well, currently that's known as the MESH terms, medical subject headings, and they're too slow and often inaccurate. In particular, we just built this thing and we store it in Postgres, and we do a trigrams full text search. To do that, it requires a large nested query. It's super slow. And it doesn't even return the best results, because trigram search are just searching for letter matching, which isn't actually the most relevant term for you. So what I did is I used AWS Zapto Lambda serverless instance that goes to mesh terms, and it builds this, it's a homebrewed ETL. So it grabs the mesh terms and the studies database of all the studies we search, and it builds a popularity table, very easy, of all of those things, and it loads it into Elasticsearch as weights. And Elasticsearch has autocomplete built in, and you can do a weighted autocomplete thing. And so all we have to do now is, instead of query Zappa and do this on the mesh terms, we can just ask Elastic Cloud directly to do autocomplete for us. Super easy, right? But now the terms are far more relevant, and I can improve that by improving the ETL. Instead of using the actual terms in the studies, I could actually use the characters and what they end up selecting on the site by gathering that data. I didn't have time to do it at the time, but you can imagine, if I type in the words AL and I typically immediately select ALS, that I now know that, and I could use that data to suggest the next time a person types AL to immediately suggest ALS instead of wait for the S part to actually suggest ALS, as an example. So the final example is Meet Me at Tagged. It's an example of a non-traditional use of a recommender system. The problem was the site had 20 million page views per day, of which all of it was the viral flow because we had 30 million users at the time. So what they did is they tasked the 4 top people of the company, I was the architect, so I was one of the 4, to come up with a way to make the site sticky. I can't tell you, I came up with this idea. So what happened was I was at Facebook had their first F8 in May of 2007, and I was hanging out with a company called Hot or Not that was incubated out of the same offices as Tagged. And they had a product called Meet Me, where you meet people on Facebook. That's their idea, at least. And it failed like hard because you can only meet your friends. And I had this thought. That it's the Facebook API was the problem, because the API only exposes your friends list, and who wants to meet people they already know? So I had this idea that, well, I have tons of users, so why don't I just do it on our own system? So what I did is, it's not a simple problem because I can't show your friends list or friends of friends, because this is not, you want to meet strangers. But it shouldn't be random, so I have to recommend those people. So what I did is, we were in PHP, I go to Oracle, and then I build this network of users in Java, and all their relationships, okay? And we store all that stuff. I have PHP store basically this big thing in the data warehouse of all these relationships, all these transactions that are going on. And then Java can go in and take the data from those two and generate this model. So now when the user logs into the site and they want to play this game called Meet Me, they go, and what they did, this is 2007, they go in and PHP goes in and it asks Java, and Java will go in and generate this Monte Carlo list. So what it does is it trolls this network that Java's built out. It trolls it, I believe, it goes down this network 40 million times, and it goes 9 steps down the network, and whoever it ends up on, 9 or 11 steps. There's a reason for that. It has to do with gender bias. And generates this list of 40 million endpoints. Okay, it sums up that list, it reduces it down, and keeps the top 1,000 most popular endpoints, and generates this ranked list. It's a recommender system. It's just a little more complicated than the regular one. It caches and returns the top 20 to PHP, who then sends like 5 down to the user, and then when the list is running out, it grabs the next group, and then when the list is the whole list is starting to run out, if the user is ranking like 500 people, then it asks it to run this model again and generate another Monte Carlo list. Okay? And then it can suggest people who you want to meet, right? The better we can improve this map of people's relations, the better it will actually return people you might want to meet that you're not currently friended in. There is a content filter inside PHP that filters the list down, because we found our site was very popular. As an example, the site was very popular in places in the Middle East, like Iraq or Saudi Arabia, and for some reason, if you are a blonde California girl, they would just select yes, and so the ratio was very skewed, so we needed to tap that down a little bit, so we did some content filters so that there's a good mix of those results, right? You just I told you keep doing that. So you may, sounds like something familiar, maybe. And I will say that I don't even remember what the other systems were. The other 3 projects, the CTO, the CEO, and the Director of Engineering were working on. Because the first week after I launched Meet Me, we doubled traffic to 40 million page views per day. The average user was rating 200 people in a single session. And by 2009, Meet Me was doing 100 million pages per day of dynamic pages. That's like about 300 million dynamic requests, because we only call a page when we change the banner ad. So users are rating so fast, we don't change the banner ad very often. So they're rating a lot of people. The site was 250 million total, or 7 billion. It became the 3rd largest social network, as you can see on the back of Meet Me. And this may sound familiar because you're rating profiles, profile pic to meet strangers. That does sound familiar. In 2012, my yearbook took that same idea and they renamed themselves to Meet Me, literally the product. And then Match.com copied them. And then you have heard that product. It's an app with swipe left. And then 2016, MeetMe.com buys out Tagged after Tagged tried to countersuit. But I was gone a long time before that. And besides, I stole the idea from Hot or Not, so who cares, right? So it's not like I'm that original, right? So I was done doing evil shit. So in summary, recommender systems are certainly possible. They're the use of business analytics for the benefit of the user. Business analytics may seem like magic, but I explain the magical terms and you can figure it out if you need them, but you can also do them without them. And your mission, impossible, is to use a recommender system, build the intuitive UI. Those are the 3 points in my talk. So now I'm done. This presentation will self-destruct. And here's my information. Thank you, Confoo and Yan, for accepting this talk at the last minute. If you have any questions, come up to me. I'm also on all the social networks. I'm very lazy, so mention that we met at Confoo. Here's the slides from the talk. I'll post the video of the talk at the when I have a chance. Just this if you want to see all the builds and things like that. Come up to me after if you want to talk to me, or just find me on the social networks and say whatever. Thank you so much. I appreciate it.